Hey Kim Stars, welcome back. Today we are going to talk about percent composition, but first we must review of molar mass. So remember, this review goes on the left side of the notes that you took about molar mass. That way you can look back and forth. So you're supposed to find the mass, molar mass of two substances. We've got potassium peroxide and silicon dioxide. So hit pause and meet me at 4:3. Okay, so here we are at 4.3. Remember, across the top, your title is 4.3% composition. And then this is page 26. All right. Percent composition is very, very simple. In fact, it probably should have went ahead and went with our molar masses, but we'll be okay. All right. So percent composition tells us the amount of an element in a substance. And a lot of times this is helpful for us when we've figured out how much is in a substance. We can kind of work backwards and find the formula for it. So very, very simply, we have 3 steps and they are super simple, and it's just like finding percent in this class. You would find the molar mass, and then you would divide the element's total mass by the molar mass and then multiply by 100. And obviously we're going to label with a percent sign. And again, we're going to keep just 2 decimals. All right. We're going to just keep 2 decimals there. All right. So those are our 3 steps. Very, very simple. So let's see if we can't do a couple of examples. And yes, we have already found the molar masses of these elements, but I kind of want to review with you on that. So our first step that we're going to do is, remember, we need a periodic table and a calculator handy so we can do this. So let's go ahead, and we're finding the mass percent of each element in H2O. So that means we've got to first find our molar mass. So we have H2O. So we have H and O. Then we have 2 H's. So we're going to take that times the atomic mass of H, 1.00794. Remember, I found that on my periodic table. That's the bottom number. Then I'm going to take 1 times 15.9994. This gives me 15 point, that's not a 9. 9994. And up here we're going to get, that's a different number, 2 times 1 point. We should get 2.01588. Now we add these up, right? That would give us our molar mass when we add these up. And so we get 18.02. Remember, we round. And that's our molar mass, right? We labeled this. This is what we found out how to do in our last video. Then we labeled it with grams per mole. Now, our next step says to divide the element's total mass by the molar mass and then multiply by 100. How cool is this that we have kind of our table already set up for us? So we're going to divide hydrogen by the total mass. So we're going to divide by 18.02 and then times by 100. So we're going to take 2.01588 divided by 18.02. And then times that by 100, and we should get, remember, we're keeping 2 decimals, so we're going to say 11.19 is what my calculator says. 11.19% is hydrogen. So 11% of the mass in a hydrogen or in a water molecule is hydrogen. 11%. So since there's only 2 atoms, we could very easily take 100 minus this 11.19 and find our oxygen, which is around 88. But we're going to go ahead and do the same thing again just to make sure. So, excuse me, had a sneeze there. All right, so we're going to take 15.9994 and we're going to divide by 18.02 times 100. And we got 15.9994. And we're going to divide that by 18.02. And we're going to get 88.79%. 88.79%. And that is, if we add those up, if we check that out, we've got 88.79 plus 11.19. We should be really, really close to 100, and we are. So that is finding the percent mass of each element in there. All right. So that's our first one. Let's try the same thing down here, except it takes us just a little bit, it makes it a little bit easier for us. In fact, it says find the mass percent of oxygen in iron 2 chlorate. If you remember in our last video, we found iron 2 chlorate. Its formula was Fe, parentheses, ClO3, parentheses 2. Yes, you could have just flipped back and found that. So now we have iron, we have chlorine, and we have oxygen. So 1 iron, 2 chlorines, and 6 oxygen. So we're going to take times 55.845. Even though we're just finding oxygen, we still have to do this step because we've got to find the molar mass. So we're going to take 2 times 35.4527. Sorry, my decimal didn't show up there. All right, 2 times 35.4527. And yes, you could have just referred back to yesterday, but why not keep practicing molar mass, because we will use molar mass a ton the rest of this semester. So we're going to take 6 times 15.9994, and that gives us 95.9964. And remember, we add these up, and hopefully we get the same answer that we got on the last video. That would be not good if we did not. 222.75. All right, and remember we labeled that with grams per mole. Let's check back and see if that's what we got last time. Whew, it is. Whew. Starting to get worried there. Okay, so now it says find the mass percent of oxygen. So we don't have to do iron and chlorine. We can just do oxygen. So we're just going to take and divide 95.9964 by 222.75. And then we're going to multiply by 100. So 95.9964 divided by 222.75. And then times that by 100. And we should get 43.10%. So 43.1% of this is oxygen, of this compound. So almost half of it is oxygen. Okay, awesome. See you in the next one.